Hello, everybody. Thank you for joining the Western Center for Ag Health and Safety seminar series. We are going to get started in just a moment, but first want to let you know that we have interpretation. So you're welcome to select English below or Spanish. Fanny, could you do an announcement in Spanish to let our guests know about that?
Sí, bienvenidos y gracias por unirse a nuestra serie de seminarios.
Welcome and thank you for joining this series of seminars. We are going to give a few minutes so that everybody else can connect. Right now, Fanny is giving instructions regarding interpretation since we do have it available. If you're listening to me in English, this means you have successfully joined the interpretation channel in English.
Okay, well, as we get started, I'm going to go through a few housekeeping rules. Elizabeth, if you would switch slides. Thank you. This seminar is being recorded in both English and Spanish and will be posted on our YouTube channel in the next few days. All participants are muted. However, you can use the chat function to submit your questions for the question and answer session at the end of the presentation. And as we just said, Spanish interpretation is available, and so you can choose the English or Spanish from the interpretation language selection below, and that looks like a circle, a globe icon right at the bottom of your menu. You can also choose closed captioning by selecting the CC icon below and clicking Show Subtitle. Just to introduce those of you who are not familiar with the Western Center for Agricultural Health and Safety, we are one of 12 NIOSH funded ag centers with a mission to improve the health and safety of agricultural workers in the West through research, interactive trainings, and tailored outreach. And that's because agriculture is one of the most dangerous industries. Today, we're going to hear from Emily Bryson, who is a scientist at the Department of Pesticide Regulation, and she's going to talk to us about emerging technology, which is most definitely an area that is necessary for both research, trainings, and outreach, because technology is at the forefront of agriculture. So if you can go to the next slide, I will see the proper title, DPR's Emerging Technologies Workshop. And so again, we have Emily Bryson to talk to us. She's a senior environmental scientist with DPR, and we're really lucky to have her here with us today to talk about the work of this work group, and looking forward to a nice discussion at the end. So Emily, I'll turn it over to you.
Thank you, Heather. I'm going to go ahead and share my screen here. Hey, so hi everyone. Thank you for being here today. My name is Emily Bryson. I'm a senior environmental scientist with the Worker Health and Safety branch of the California Department of Pesticide Regulation. And as Heather mentioned, I'm here today to talk about our Emerging Technologies work group. I founded the work group and chair the work group. And so I want to tell you why we needed to do that. So first, I want to talk about the incredible people I have in my work group. Since you're familiar with the Western Center for Ag Health and Safety, you probably recognize a lot of these names. But we really wanted the group to be a collaborative effort between experts from academia and regulators to help us build on our understanding of these technologies and ensure that we're making informed decisions as we think about what to do with these types of technologies. So we have representation. We have representatives from UC Davis's School of Biological and Agricultural Engineering, representatives from the University of California Ag and Natural Resources, a lot of representatives from DPR. Oh, you know what? I think I have timing on my slides. I'm so sorry. So the reason we have so many representatives from DPR is because we wanted to include people from all the different branches that might be affected by these types of technologies. So we have people from our enforcement group, from registration, from human health evaluation, who do our risk assessments. We have representatives from our evaluation branch who look at what products are being registered in California, our environmental monitoring branch, our licensing group. I'm probably not including everyone, but really anyone who might be affected or might have to make decisions regarding these types of technologies in the future. We also have the California Department of Industrial Relations, including Cal-OSHA and the OSH Standards Board. The OSH Standards Board works with Cal-OSHA to make decisions and change regulations when they deem it necessary. We have the representation from the California Department of Food and Agriculture and from UC Davis's Department of Plant Sciences. So I really do get very excited when I look at this group, because we really do have some superstars in the field of ag tech, which has been tremendously helpful as questions have come up. So I wanted to talk a little bit about what emerging technology actually is from our perspective. So emerging technology itself is really broad, broader than the scope of emerging tech that we're looking at. And the reason is because DPR is tasked with regulating the sales and use of pesticides in California. So something like the pesticides coming out of application equipment is regulated by DPR, what can and can't be applied. The handler or applicator on the equipment is regulated by us, how they can appropriately apply pesticides, what they need to do, what personal protective equipment they need to wear. We haven't historically regulated equipment. So, that falls under Cal-OSHA, and it gets really interesting for us when you take the handler off of the equipment and you're using something like artificial intelligence and machine learning to decide when and where to apply pesticides. So that's a big part of why, we had to talk about this group. We had to start talking about these types of technologies. So in that regard, any technology that our work group looks at applies pesticides. There's a lot of tech out there that replaces pesticides, like some of you may be familiar with things like robotic weeders, where they're using robotic weeding in place of herbicides. Well, that's, great. That wouldn't fall under our jurisdiction because it's not applying pesticides. So we are platform agnostic. So we include things like teleoperated unmanned aerial vehicles. So drones, if you're operating a drone from the side of the field with a remote, fully autonomous unmanned area vehicles. So solo and swarm. Solo is when it's applying by itself. Swarm is when multiple drones are working together to make applications. Self-driving and retrofitted tractors. We're seeing more retrofitting kits where they're taking existing tractors that typically have a person driving the tractor, and they're using either software or hardware to retrofit the tractor so that it can drive itself. Fully autonomous ground rigs, targeted application technologies. This is not a comprehensive list. There's more tech out there than this, but I wanted to kind of give you an idea of some of the things that we've looked at so far. Excuse me. So the structure of our group really at this point is focused on information gathering and roundtable discussions. And that's really the take-home point, I think, for today with these types of technologies, is that we're really trying to gather as much information as we can and build some in-house subject matter expertise within our department, so that when questions come up, when we're looking at our regulations, we have people who we can go to, because we're a department of scientists. We don't have engineers, because I mentioned earlier, we don't typically regulate equipment. So, we really want to ensure that we have that knowledge, that we have that understanding of how this tech works. We have guest speakers and demonstrations of emerging technologies. We've had incredible volunteers from industry who want to come out and tell us about their technology. They're very eager to have conversations about this tech and about the safeguards that are built into it, all the different ways that it can be used. And demonstrations, of course, are incredible. We review current and emerging regulations at the state and federal level. So we really want to keep our finger on the pulse of what's happening outside of California, in other states, federally, even outside of the US. We're starting to see some regulations come into play, especially international regulations. We also look at things like best management practices, guidance documents. I've been really fortunate to be able to have discussions with the ISO standards board, who develops standards for the development of this type of technology, to work with a bunch of task force who are working on best management practices for these types of technologies. So we've been really lucky to get in on the front end of some of this, because we really want to ensure that companies kind of know what regulations they have to follow as they're building this type of tech. The inclusion of other regulatory agencies to share resources and connections was incredibly important to us. As I mentioned, this is a paradigm shift in agriculture. There's a ton to learn. And I think as regulators, there's no way for us to move as fast as the tech is moving, right? So the more we can share data, we can share resources, the easier it makes it for all of us. I also participate in US EPA's ag tech work groups. I'm in US EPA's emerging technologies work group and the targeted application technologies work group, representing California to see what's happening at the federal level. The two work groups were recently sunsetted, I should mention. So they're going to be starting up new work groups soon, but essentially the role of those work groups is to answer questions about ag tech that EPA has their Office of Pesticide Programs, and to kind of make recommendations to US EPA on ways that they need to approach this type of technology. We also have branch-specific topics for DPR representatives. Again, not a comprehensive list. This is just a few of the things we've talked about so far. So things like licensing of remote operators. I want to give an example here that has come up many times for our work group. DPR licenses applicators of pesticides. And so one of the licenses that they do is for aerial applicators who are applying by a fixed wing airplane or a helicopter. And so one of the things that's required to get that license is time in flight, where you've actually flown an aircraft prior to applying pesticides in one. So when you have someone operating a drone from a remote at the side of the field, that could be a problem. They may not have those manned flight hours. So, that has come up. Evaluation of our current regulations, where these types of technologies do and do not fit into our current regulatory framework. Proposal of future regulations, that is, again, right now we're information gathering. That could be down the line if we deem it necessary. Worker and bystander safety. So I'll talk a little bit more about that. And like I said, I'm worker health and safety. So that is a big part of why I got involved with this work group. Evaluation of label language. So if you're familiar with pesticide applications, the label is the law. And so you have to follow whatever is on that product label. So when you're talking about some of these technologies, they're not necessarily on the pesticide labels. Well, they're definitely not on the pesticide labels. And so one of the things we've done is look at label language and see where it may inadvertently inhibit the use of this technology, where it could be a problem for this type of technology, because we do, for DPR, we register products in California in addition to the federal registration process through US EPA. We talk about technology coming down the pipeline. So that's really important. I know that there are a lot of people I've talked to outside of California who are struggling with how to approach this type of technology because of that pace I mentioned earlier that technology moves at. And so typically, you look at past cases of incidents and then you decide, on the safety of it based on historic data. But because this technology is evolving so quickly, it's really important that we know how it's shifting. Environmental concerns, and then the risk assessment process. So, when we're talking about where people are during an application, where, field workers might be, where applicators might be. That could be very different with these types of technologies. The application itself could be very different. So it makes the risk assessment process really interesting. So these are some topics of discussion.
Estos son
Again,
algunos temas de discusión.
Sorry, something may have come up. This is not a comprehensive list of the things we've discussed, just a little overview here. So we've talked about the capabilities and limitations of this equipment, things like drift prevention. So in speaking to a lot of manufacturers of this equipment, when they're thinking about the safeguards that need to be built into these types of technologies, they're thinking about obstacle detection in terms of not hitting someone. So you have someone sleeping in a field, or you have an animal run into the field. How do you keep the equipment from hitting it? But as I mentioned, our regulatory role is to prevent people from having contact with pesticides. And so, thinking about how far it stops away from an unexpected obstacle, how quickly it stops, things like that are really important for us. So emergency shutoff. Another thing that we've talked about is the connection to the remote operator, whether that's Wi-Fi, cellular, Bluetooth, satellite. This could seem like it's kind of getting in the weeds, but the reason is because we know that many fields won't have reliable Wi-Fi or Bluetooth connections. And we know that satellites sometimes have lag time between the time that they encounter something and that they communicate with something remotely. And so we want to know, how reliable is that connection? What happens if it's dropped while it's applying? How does that lag time affect drift potential if they're using a satellite? So things like that are important when we're thinking about drift. Assigning liability is another one that's really interesting when it comes to these types of technologies. I'll give you a classic example here, and it gets way more complicated than this, so I'm definitely oversimplifying it. But a classic exposure example would be someone is applying to row crops, and they're coming around, this is a manned ground-based equipment, and they're coming around the corner of a row and they forget to shut off their nozzles. And so they go around the corner, car passes by, bicycle passes by, someone gets sprayed. It's really clear who's liable in that case, right? But if you're talking about things like upgrading software or manufacturer defects or AI or machine learning, maybe making the wrong prediction of where something is, if you're talking about losing a Wi-Fi or cellular connection to someone who should be getting a signal that something entered in the field that wasn't expected to be there, liability gets really interesting. We also talk about the applicability of our current regulations, label language, and licensing, like I mentioned earlier, where this technology does and doesn't fit into the current regulatory framework. Understanding our regulatory authority. This seems like it would be obvious, we're regulators, we should know, but it gets really interesting here because, like I said, if you're in a field and you're using autonomous equipment and it hits someone, that's Cal OSHA. If you're in a field and you're spraying and you spray someone, that's us. But this is new to us. We don't regulate equipment. So, it's understanding that regulatory authority, I think, is really interesting. And just the information gathering process, if there is an incident, is totally different. We also want to provide information to equipment manufacturers. So this was really important to me. I write regulations because I want to keep people safe. I want them to comply with the regulations so that they're protected. I don't want to see them get fined down the line when something goes wrong. And so I really want us to be kind of an open resource for people developing this technology. I've been really fortunate to meet with some incredible manufacturers, a ton of manufacturers who are making this technology. And I found that it's very different in that many people historically in ag have been in ag a long time. But with this emerging tech, I'm seeing more startup companies, students right out of engineering programs who have these great ideas, but they might not have on-farm experience. So they don't know that as soon as they, put something on their machine that could apply pesticides, even if it's a small amount, even if it's in addition to other equipment that's on there, that they have to comply with our regulations. They don't know what the laws are and how to comply with them. And so we really want to be there to answer questions as we can at this point. And then, as you saw earlier from my rock star lineup there, we also take work group member recommendations because we're very fortunate to have some really great experts in the group. So another thing I want to talk about is California's Sustainable Pest Management Roadmap and emerging technologies. DPR has played a major role in designing California's Sustainable Pest Management Roadmap. The roadmap sets very ambitious goals to make agricultural and urban pest management safer for human health and the environment over the next few decades. So by 2050, California pest management approaches in both agriculture and in urban settings is meant to become more sustainable, protecting human health and safety, ecosystem resilience, agricultural sustainability, community development, and economic vitality. And there are a lot of different approaches. The roadmap sets these very big goals to do that. And this is by no means a comprehensive look at the roadmap. If you're interested in it, it's available on our website. You can find it. You can read the whole thing. You can read about all the goals and how we want to achieve them. But two of the primary goals set are to eliminate the use of priority pesticides by transitioning to sustainable pest management practices by 2050. Priority pesticides have not been defined yet. We have a really big, diverse work group defining those pesticides now, but they will be selected on the basis of adverse human health effects and environmental impacts. The second primary goal is to ensure sustainable pest management has been adopted as the de facto pest management system in California. So one of the things that I wanted to know is how emerging technology fits into this roadmap, because there are a lot of different ways that you can make pest management more sustainable, and there are probably integrated pest management people in the audience who could talk to you a lot more about it than I can. But there are a lot of different tools that are going to have to come into play to achieve such ambitious goals. And so one of the things that the roadmap specifically talked about was earmarking funds for technologies. So it specifically talked about things that replace pesticides like robotic weeders, and funding for both development of this technology in the agricultural and in urban pest management spaces. So there's a lot of tech that falls kind of in this idea of more sustainable pest management. So this is not the only technology that does, but I wanted to kind of give an example of some of the tech we've looked at. And again, there's some that's really obvious, right? You're replacing the pesticide with some kind of robotic implement. But in this case, this is kind of a different thing, and something that our group has talked a lot about, and that's targeted applications. You may have heard it referred to as see and spray technology. There are a lot of different names for it. Again, it's equipment agnostic. So we see ground-based targeted application technologies, air-based, so UAVs. And right now, and this definition, I should say, was created by a group of regulators. So it's we have to talk and write in a very specific way. So I'm going to give you an abridged version. But right now we're defining it as an application that is an application that is informed by a prescription, scouting, and or sensing result, including real time while the application is in progress, which improves delivery of a pesticide to target the intended pest, for example, the weed, insect, fungus, in small or irregular areas within a larger use area. So something like the section of a field, fairways at a golf course. This contrasts with broadcast applications, which treat the entire area, or strip band applications, which treat a narrow continuous area within the larger use area. So essentially what this means is you use something like a sensor or scouting or some kind of implementation on your machine to find the target pest and to apply a pesticide directly to it. So I've seen companies describe it as a squirt gun spraying directly on your weed or your pest or whatever you're intending to spray it to, versus going through an entire field when you have weeds and spraying entire rows of crops so that you can get those weeds. Variable rate technology can be incorporated alongside with targeted application technology, but I just wanted to mention VRT and targeted application technologies are not synonymous. So this is kind of its own unique thing. So I wanted to give some examples of what this looks like, but because I'm the government, I have to say these are not to be construed as either actual or implied endorsements for any of these products. This is just to kind of contextualize it for everyone, because it can be, you know, interesting to kind of wrap your mind around what this type of stuff looks like. So this is the GUS Plus Smart Apply. We see it in orchards. For use in orchards where you're typically using an air blast sprayer that's going to spray up and above your crop canopy so that you're hitting the top of your crops. The GUS Plus Smart Apply is self-driving, so there's no one operating the equipment on the equipment itself. LiDAR senses foliage and activates individual nozzles to directly target the pest. So if you're not familiar with LiDAR, again, I'm probably not the best person to explain it, but essentially the way I understand it is you're using lasers, you're sending out lasers from a point that are refracting off objects around the equipment and basically hitting every solid object around them. And when they refract, they essentially create a 3D map that's moving with the equipment of all the solid objects around the equipment so that it's getting a real-time map of everything around it. They found with this technology that there was a 50% average pesticide reduction overall and up to 87% less drift. These figures came from research from USDA, ARS, and various universities. You can also retrofit this on previous GUS models, as well as most new or used air blast sprayers. So that means you can use that Smart Apply system to take any of the GUS self-driving ground rigs or air blast sprayers and do a more targeted application. The Gen 2 Smart Apply automatically generates documentation of chemical use savings in real time. I mention this because DPR also has the pesticide use reporting database. So we collect information on every pesticide that's applied in California, and we make that publicly available on our website so you can see where pesticides have been applied. And it's within a mile radius. And so this is really interesting because you're getting, the exact amount that was applied. So another company is Verdant Robotics. Verdant Robotics uses 68 to 96% less pesticides. That is based on information provided by the manufacturer. And you've got spray with millimeter accuracy and precision based on 4D models of the crops that are created in real time. So again, you're using those real-time systems to see where your weeds are, and then use like a soaker spray to spray directly on them. It also includes a laser weeding system in addition to the chemical weeding. So they're using lasers to hit those weeds. So there are other mechanisms to kill them besides the herbicides. And excuse me, one of the interesting things about Verdant is that they offer robotics as a service. So another question that our emerging technologies work group has received quite a bit is how will these types of technologies be accessible to smaller farms? Because, with these ambitious goals set by the Sustainable Pest Management Roadmap, I think it's going to take a lot of interaction between different farms to keep pest pressure at bay, right? So they want to know how can we access this? And so that robotics as a service is essentially like a subscription-based system like Netflix, where you subscribe and then they come out and they do that weeding for you with their tech rather than you buying the equipment outright like a lot of the manufacturers do. So another thing to mention is that in California, like I said, there's some jurisdictional overlap between ourselves and Cal OSHA. So They do have a regulation under Title 8, subsection 3441, which is the operation of agricultural equipment, that requires that all self-propelled equipment shall, when under its own power and in motion, have an operator stationed at the vehicular controls. So one of the first things when I pitched this work group, when I started this work group, I wanted to know what their definition of vehicular controls was. Does it include, an iPad when someone is operating it from their couch? Does it include a remote operator who's standing at the edge of the field, teleoperating the equipment? And the answer that I received is that it does. It only includes someone who is stationed on the equipment itself at the vehicular control, so a driver on the equipment. So Cal OSHA has had quite a few petitions to amend this regulation to allow for the use of what they call the highly automated and autonomous agricultural equipment. So when you see that HAAE, that's what that is. But they do not permit the use of the self-controlled, highly autonomous equipment at this point. So Cal OSHA does have, they allow for the operation of such equipment via their experimental variance program, which they use to evaluate new and improved techniques in occupational settings to safeguard the health and safety of workers. Excuse me. And so essentially what it means is someone who wants to operate this equipment needs to apply for experimental variance through Cal OSHA. And then over a number of years while they're under the experimental variance, Cal OSHA can collect data on that equipment. So a big part of why I wanted Cal OSHA and the OSH board in the room was to share data and connections and discuss data gaps related to these types of technologies. Excuse me, I'm so sorry. Because there's so much to learn. And like I said, regulators are kind of really trying to keep up at this point as it's moving so much faster. So, there's a lot to learn, and I really didn't want us to work in silos. So we are really trying to work together on this. So that's it for me. I wanted to open it up for questions at this point. Thank you all. And please feel free to ask away.
Wonderful. Thank you so much, Emily. Really appreciate the thorough overview. Why don't you pull down your slides? And we do already have one question. And I will just remind folks, feel free to put questions or comments into the chat and in either English or Spanish, and we will be happy to, I will be happy to pose them to Emily. One question is specific to the GUS Smart Apply machine equipment, and that it might reduce pesticide use, but doesn't seem to fit your definition of targeted application, because the pesticide is applied to all foliage and not determining whether or not a pest is present or not. Can you speak to that?
So this would probably be a better question for Gus than for me, but when I think of the Smart Apply system, I think that they and I could be wrong here, but I think that they're using that real-time data to figure out where that pest pressure is and make more precise applications with that technology than doing like a full broadcast spray. I don't want to speak on behalf of the equipment manufacturers because, like I said, we are still gathering information on this technology, trying to learn about it. But in my mind, at least, I think when they're using that real-time data, when they're reducing the amount of pesticides applied and targeting pests more specifically for more precision is when that kind of falls within that definition in my mind.
Okay, thank you. Any follow-up related to that is welcome for in the chat. So another question, it was impressive to see the number of people who are on your on the membership in the work group. I noticed that it seems very internal to state agencies and representatives. Curious about whether or not folks, community members, community-based organizations and representatives, farmers, growers, applicators, others who represent different groups have been considered, especially those who might be at risk of pesticide exposure?
So because the mission of this group really started in an effort to gather information, we wanted to keep the scope pretty small. And I think I'm very excited to see this question because I've had a lot of conversations about this, about how we can bring in community-based organizations, how we can have the right people at the table. I think right now it's too early in the process where it would be maybe too many cooks in the kitchen at this point, because we are really just trying to learn versus getting into the issue of training workers. But I have had incredible conversations, and one of the people in the work group is Gabe Yautzi, who is the Chief Innovation Officer with the University of California Ag and Natural Resources, and he works over a program called F3 that is working with workers in the Central Valley and a few different regions to train them to shift their training from traditional field work and handling to operating this technology. And so we're seeing more of those efforts. So those conversations are being had, and I hope eventually we'll move to that place once we kind of have more information. But I think right now it's too early for us to start having those conversations, because right now we're just trying to wrap our minds around what is out there and how it differs from traditional application equipment.
Got it. A question from one of your members, Farzaneh, is asking, and one of our center members and PIs, what are the pros and cons of using laser weeding?
Oh, I'm the wrong person to answer that question. So I will tell you, and honestly, Farzaneh could probably answer this better than I could. But I will be honest and say that once equipment stops applying a pesticide, it's no longer in our jurisdiction. So if you're talking about the laser weeders, that is no longer in our jurisdiction at DPR. So it's really, that would honestly probably fall under Cal OSHA. There are a few things, that could potentially maybe fall under Cal EPA, like the use of refrigerants to cool the lasers. But if it's not using pesticides, it's outside of our jurisdiction. So I'm sorry, I'm the wrong person to answer that question, but I'm sure that there are people in my work group who could. So I'd be happy to follow up on it.
No, I think it highlights the complexity of this area of work that you're in, because small little nuances related to ag tech push it from one regulatory body to another, and it's not necessarily obvious to the people developing the technology and shifting from one small, it might be a small move for them from an engineering perspective, but it changes entirely the regulatory bodies that they need to be thinking about working with.
Yeah.
Another question related to the worker protection standard and the trainings related to pesticide safety, applicator trainings. How is that training module being thought of, and the implications related to it and these new types of applications?
So we have worker health and safety representation in the work group, myself and someone else, Alexis Cugini, who's wonderful. And we are, that is part of our role, is kind of trying to figure out how and when that will have to happen, if it has to happen, but we haven't got to that point yet. So, I think right now we're still, and I'm sorry to be on repeat here, but we really are still gathering information and determining what does need to change, where this can fit in, where it doesn't, into the current regulatory framework. And so, these are the kind of conversations we're having, is looking at things, going through the regulations and looking at, where we may need to add something, where something may, be problematic for this type of technology.
Sure. Okay, another question. Do you see it being difficult for DPR to be able to assess sustainability when the alternatives are not under DPR's jurisdiction? For example, equipment as an alternative.
So, you know, I'm not part of the Sustainable Pest Management Roadmap work group, but, you know, I think that from what I've seen in the Sustainable Pest Management Roadmap, it's a shift toward anything that is, you know, replacing those priority pesticides that are making agriculture safer. So I don't think we're necessarily, you know, putting out a list of like, here's the best stuff, but more shifting toward reducing that and using different means to do it. So I've seen things like, you know, historical cultural practices to sustainable farming being implemented, you know, traditional farming techniques where pesticides aren't used. Biologicals, of course, are going to be a component in that, replacement of synthetic pesticides where possible. And then emerging tech is another aspect, but I don't think that we're really, we're not going to dictate what can and can't be used. I hope. I don't think so. So, you know, I think it's going to be more of what are the potential tools to reduce the priority pesticides, what's available. And, you know, so I think that that's going to be a big part of the conversation moving forward. And that's part of this is trying to learn what is available from the emerging tech side.
That's really exciting. I think that you received a question that was sort of getting at that for example, there's a precedent that heat has been used to kill pests and so forth. That sort of there's a range of other non-devices, right? Yeah.
Yes, absolutely. And that was a big thing that we talked about early with the emerging technologies work group was what counts as tech. And so someone brought up the idea of like a hooded sprayer where you're putting a hood over your nozzles to reduce drift, or something like a canopy over an air blast sprayer that's reducing the drift coming off the air blast sprayer. You know, does that fall under the definition? And so for just the simplicity of the group, we really are looking at equipment itself, but there are so many things out there that are going to be a part of, you know, making farming more sustainable in California.
Okay. So another question came in about violations coming in and whether you're seeing an increase in violations related to an increase in emerging tech, and just curious if you've been tracking any trends in that regard.
I think at this point, so we do have enforcement in our work group. They're a big part of our work group. We have our regional offices and we have our headquarters office. And so honestly, they would probably be better to speak to this. But as far as I'm aware, you know, I can say there's not a lot of this tech operating compared to traditional application equipment right now in California. There's certainly some, and I don't want to put a number on it because it would be totally arbitrary, but I don't know, but I don't think it's at a scale at this point where we would be seeing an increase, I guess is what I'm trying to say. I think it's, you know, we're still in the really early phases of this equipment.
Okay.
Coming into play.
Yeah. But the interest is obviously high. I mean, there's a lot of really great questions, and I'm so glad we've had the time for it. So another one coming in, if it is a concept that an automated device spraying pesticide can be hacked, what is being done to assess how easy can such devices be hijacked? And I'm thinking here about how surprisingly easy it is presently to steal an electric car.
So this is something that was brought up recently in our work group, and I will say we have not, it's definitely a conversation that Cal OSHA has had, you know, something that has been brought up. I think we're so early in the information gathering phase that the hackability, the stuff like that has not, we've kind of talked about it in some regard when we talk about liability, but not at a point where, you know, we can say anything definitively about how we would approach that. I mean, I think at this point, we're still trying to figure out things like how would we even investigate when, you know, this would be a completely different investigation in the event of an exposure than it would where you go out and talk to the person who is applying pesticides or the people who were involved in the incident. So, you know, these are still a lot of conversations that we're having. So yeah, I'm sorry that I don't have a better answer for that, but really it is, the conversations are being had. We're just not that far along yet.
I'm curious whether there's, and I don't know if you're the right person. I mean, it might be a matter of talking with, you know, some of the association groups and others, where to hear the network of growers and farmers and farm labor contractors who are out in the field to find out what's currently happening, you know, because I imagine there can be a lot of experimentation. A lot of things can be easily, you know, kids get really cool drones for Christmas, or, you know, I mean, there's just so much that can be easily acquired. And I can imagine that some potentially really dangerous activities can happen very easily and fall through the cracks. And I think that this must be, for someone like you, a pretty scary prospect. And I'm curious how quickly you think DPR can move, because as you and I were discussing, tech moves much more quickly than almost anything else. That just the movement of technology and development is very quick.
Yeah, well, and I think, you know, in the cases where, and this would really be a question for our enforcement group, but in cases where there is a pesticide exposure, DPR works with the counties to go out and investigate. And so I think this would be the same situation, case by case basis, where we would go out. And we do fortunately have some people. I know you mentioned UAVs. We have someone in our enforcement group who's done some work with UAV operations in the Central Valley. And so I think that in terms of us understanding everything that's out there and how it's, you know, I hate to use the word hackable, but really hackable, so that you can change up, you know, how you're doing something. I think we would approach it really the same way that we approach traditional equipment, and going out and doing that investigation and seeing, you know, what occurred, you know, following up where we can. It's just a very different I think it would be a very different investigation in some ways, but yeah, I think we would respond the same way. But I shouldn't. I think that would be an enforcement question, I will tell you. So if you'd like to follow up with me, I put my email address on the presentation. So if there's anything that I haven't been able to answer, or where I said there's someone else who's better to answer this than I am, feel free to follow up. And I also see Mike Zeiss, hi Mike, put up something in the chat where we have actually regulated some equipment in the past, like structural pest control devices. That's true. So this is, you know, different than that. But there have been you know, a few things where DPR has been involved with equipment, but it's this is a quite different in that we're really just trying to determine, like I said, how this technology does and doesn't differ from traditional equipment, and how, you know, regulations may need to be updated, or Heather, you mentioned training requirements. There are a lot of different places where excuse me, we've seen that this technology does and does not fit. So
Right. And thank you, Mike. I put your post, your comment with the link into the chat for everybody to access. And Elizabeth or Fanny, if you could grab Emily's contact information and put it in the chat for everybody. Since Emily, you offered it up to the audience, we'll go ahead and do that. And I also appreciate, Mike, I called out that the growers and farmers might have some insider information about what's going on the ground, but we obviously also work really closely with community-based organizations who are closely connected to farm workers. And they are the ones who are in the fields every day and have the risk of being exposed to pesticides, and are oftentimes working closely with applicators. And so knowing from them what's happening and what their experience is also essential. So I'm really looking forward to the future of the working group expanding to include those voices, because we know that that's essential. I also think it would be amazing for the companies who are building these technologies to include and engage community organizations, farm workers, you know, and the on the ground, the growers, the people who will be utilizing these, because I think that you mentioned that the back in the day, it was people more who had a history of being in farming who were the ones creating some of the technologies, and it's a little bit different now. And that makes sense. It's engineering things is really fun and exciting coming out of school, but having that connection to the farm probably makes it a little bit more applicable.
Yeah, absolutely. And I do think those conversations are being had. I just told Heather I was at FIRA 2023, which is one of the biggest ag tech conferences in the US, and last week, and that was one of the panels they had, and it was interesting to hear the manufacturers talk about the struggle to talk to growers and to talk to workers about these technologies. And so I think there's a lot of conversation about how growers can connect with the engineers and with the manufacturers on this tech to see how it benefits them, how it affects the work they do, how it affects their workers. And so I was really happy to see those conversations. It's the first, I've gone to quite a few ag tech events, and it's the first where I actually saw a few growers in the audience. So that was really nice to see.
That's great. Well, I think that's a good point to end on, because I think that's going to be essential. And I'd like for another line as part of that to be how health and safety can be part of that. You know, let's make a pitch for having health and safety at the next FIRA. I know it's going to be up here in Davis and Sacramento, so maybe we have some pull, because without health and safety being an essential part of ag tech, I think that we're you know, it's going to be hard to pass through the regulatory lines, and also it's going to, you know, have some unintended consequences. So our center is very interested in following along and being a leader in the health and safety aspects of ag tech, and we're happy to be partnering with you on that, Emily.
Thank you. Yeah, I appreciate the help. I really do. And I am so excited, like I said, to have so many members who are really the rock stars when it comes to this type of technology. So
wonderful. Well, we were so happy to have you. Thank you so much, Emily, and thanks to everyone for joining us. Our next seminar will be the first Monday of November at 4 p.m. We look forward to seeing you then. Have a great day.